Let's say we want to draw a sample size of the sum of when we roll 2 dice of 2 and 3. What's the sample going to be? Well, we can get 2 by rolling 1 and 1. We can get a 3 by rolling a 1 and a 2, or a 2 and a 1. Notice they repeat. Rolling a 2 and rolling a 3 are mutually exclusive because they do not intersect. What about Venn diagrams that are not mutually exclusive? Well, these are the diagrams that intersect. They look like this. What about an example? Well, let's take a standard deck of 52 cards. We have spades and clubs. This is what this first set represents. All of the black colored cards. The second set is going to be all the jacks. So we can have a jack of hearts and a jack of diamonds. There's 2 other jacks, right? This would be, because they are both spades and clubs, they would fall into here. All the other spades and clubs would fall in here, like the ace of spades, the 7 of clubs, and so on. These are not mutually exclusive. The complements. The prime. What does that mean, huh? Well, let's say we have a Venn diagram here, and this is the set of A, and everything inside of it is A. Okay, but then I'm going to ask for A prime. What is A prime? The prime is whatever A is not. Prime is associated with a little dash mark right there. So what is the prime of A? Well, it's everything that A is not. So it's everything in here. As long as it doesn't coincide inside the circle, it's A prime. So what about the prime, or the complement, of 2 intersecting sets? Well, we have A and B, and they are not mutually exclusive. A and B can be written this way, or in notation like this. So we know that A and B is this little surfboard looking shape right here in the middle. But I want to find the complement of A and B. So put a prime right there. That means it's priming both. So I don't want what's in A and B. I want everything else. All the way up except for this little surfboard right there. That would be the complement, or the prime, of A and B. Working with probabilities and the word or is different than and. Remember, and was a little surfboard piece in the middle, the intersection. Or, well, this is the entire thing right here, all of A and B. You can choose either or. But how do we find the probability of that? Well, it's denoted by this formula right here. The probability of A plus the probability of B minus the intersection right here. We don't want to count it twice. I'll show you what I mean. The probability of A, well, is 10%, but another 70% right here. So probability of choosing A would be 80% altogether. Let's write that down. Now the probability of getting a B, well, it's the same 70% plus another 15%, equaling 85%. Notice that we added the 70% twice, but to get the probability, we have to subtract it one more time. So, the probability of A, which is 80%, plus 85%, minus, well, the probability of A and B, the little surfboard here, is 70%. So, the probability of A or B equals 95%. Now we could have done this a whole lot easier. I noticed right away that this Venn diagram contains 100% of my entire data. Everything that is not A or B is on the outside. That's 5%. So I take my 100% and subtract the 5%. And I'm left with A or B, which is 95%.